Hello, my name is Hajime Sugiyama. I'm an industrial IoT evangelist from Mitsubishi Electric, and today, as part of my latest industry IoT trends for everybody, I'd like to talk about the future, AI, practical use of manufacturing artificial intelligence. What a decade does. 10 years ago, my parents told me, don't get in cars with strangers, don't talk to strangers on the internet. But what about today? You now call the strangers from the internet and you get into those strangers' cars. It's about technology, and it's really changed the world. It has also changed the factory this past decade. Look at this demonstration for about 3 years ago, but robots moving around, AGVs by their own, everything's controlled by a digital twin. They have beautiful sensors, they can feel, they can touch, and they're wireless. And I'm sure that the capabilities will be enriched with the 5G coming up. Last but not least, it uses AI, artificial intelligence, which is my main topic for today. I truly think that AI will make this a better world. Let's look at an airport. In an airport, there's a lot of people in need for help. A children is lost, a wheelchair person is looking for better access, for instance, an elevator. She's looking for where the check-in is. He needs to take care of his children. But the human being, it's really hard to detect who is having what kind of problem. But this is when and where this AI technology will be very, very useful. Let's look at our technology. It's detecting who has a suitcase, where's the children, is there somebody with a cane, a wheelchair? And with this technology, we'll automatically know where and who needs the support. And I'm sure this kind of technology will really make it a better world. How can AI be used in manufacturing? I'm sure there's a lot of places that AI can be used on the factory floor because, frankly, there's going to be less people on the factory floor. And with this coronavirus as well, you need to be able to manage the factory with less people, like adjusting parameters, voice and face recognition, searching for problems, and also predictive maintenance, assisting your maintenance. There's a real big part that it will play also in robotics because everybody wants to use robots, but adjusting and programming and setting up robots is not an easy job. And I talk more about this robots thing in my video, AI Applied in Robots. So if you have time, please take a look. Manufacturing AI will exist on all levels, and it's going to be a little different from the world you see in normal life. Because I think a lot of people have the image that there's going to be this one gigantic central cloud AI that's controlling everything. Why is it going to be different in the manufacturing world? It's because of reaction time. We are processing and manufacturing parts by the milliseconds with drilling and cutting, and it has to be very, very precise. In that case, you don't have the time to communicate all the way to cloud, get analysis, and get feedback. It's just too slow to go this path. And that's why we think there will be AI on various levels, on the cloud level, and the plant level, on the production line level, and on the machine and robot level, and at the end, on the motor level, which we call, over here, AI on the edge. It's very critical, and it's also very simple, because if this motor or if this robot is smart and has edge AI, you don't need to communicate all the way to the cloud. You can fastly and quickly solve the problems or detect problems when you have them. The other important thing is the factory can't stop, so it has to function when it's disconnected. In daily life, there's a lot of times where your mobile phone is disconnected, you can't get a signal, but that can't happen in a factory. You always have to be connected and you always have to get an answer when it's disconnected. So that's why this kind of edge AI will be very, very crucial. Of course, 5G will solve a lot of these problems with the reaction time and the low latency, but on the other hand, it's always a trade-off. If you want to use 5G, that means you have to put 5G SIM cards in here, you have to have routers, you have to have the networks all going. And this is going to be a cost, not only for the data costs, but for the networks and component costs. And finally, if you're using wireless, you always have to run in security issues, so you have to spend more time and more costs on assuring security. These are some major technologies of AI: reinforcement learning, big data analytics, deep learning, and knowledge processing. And we're working on these technologies and refining them in Mitsubishi Electric. We call Mitsubishi Electric's AI MySART, and the main characteristic of MySART, it's compact and speedy AI. Our goal is to make the AI very compact so we can set it and put it on devices that work on the edge, like in robots, or like in motors, or like in inverters, or like laser processing machines. So you don't need a cloud environment or network environment to have it running. How do we do this? This is just a conventional AI, but you have a lot of input and then you get an output. And you have all these branches that you need to figure out the output. What we do as Mitsubishi Electric, as we have knowledge of what input you need and what knowledge of what input you don't need, we're significantly going to be able to reduce the branches, which equals the calculations necessary to produce an output. So in one of our tests with the Mitsubishi Electric MySART AI, we were able to reduce the deep learning computing volume from 30% to up to 96%. But this is because we have the knowledge of which sensor data inputs you need and which you don't. This creates a very, very unique technology, because if the calculations you need to get the output are smaller, that means you can do it with a smaller processor. You don't need this gigantic data server in order to handle this AI. Also, we're using our knowledge as a factory automation supplier to enhance and help the AI used in factory automation. For instance, separate from the basic reinforcement learning phase, we also add what we call an advisor function, which is monitoring the success ratio of each action done. And with this, for instance, we were able to reduce the robot arm teaching time up to 98% compared to regular AI methods. And there's more and more to come, because AI is becoming more and more complex. It's just not talking about one simple task. We're combining task A, B, task C, and see if we can find the relationship. And what's another interesting technology is we're not just looking at each entity, we're also looking at the relationship between entities in order to make a compact algorithm for even complex processes. Let's give you an example of camera positioning. For instance, there's a camera moving on top of this, and it's making a picture of these letters and numbers they have on the wheels. It's really difficult for this because as the machine is moving, it always has a lot of vibration. So it needs to kind of tune, you need to tune the motor in order to make it very, very stable when it stops. In the past, this would be done by an engineer in the factory. But an engineer has its limits because he was only able to adjust 18 parameters. Because if you adjust one parameter, you have to worry about what the impact is on the other parameters. But by using AI, because it can detect and find out what the impact will be, positive or negative on the other parameters, he's able to adjust up to 720 parameters. And this is a very, very big benefit because we're not only able to reduce the setup time necessary for this by 20%, we're actually able to reduce the positioning time by 20% because the AI was able to handle these 720 adjustable parameters. We're also developing a lot of more and more fun, innovative technology like generative advisory networks where AI competes against each other. In this case, we have a graphic reading AI, which is trying to create very, very real-like AI images. And on the other hand, this detective AI is trying to detect if this is a real picture or is it a false picture. And this speeds up the learning curve for these kind of applications. We're continuously working on the future, and you'll see more and more new technologies from Mitsubishi Electric. Next, I would like to talk about practical use cases of AI. Mitsubishi Electric's goal is to make AI you can use in real life, not just for science. The first one I would like to talk about is a driver monitoring system on a car. For instance, we have a monitoring system that is monitoring the biometric information, the heart rate of the driver, and while it's doing that, it's also monitoring the vehicle information, the angle of the steering wheel. So what's it doing? It's monitoring the standard movement of the driver, and if he gets sleepy and the handle is moving too much or his heartbeat is changing, it will automatically send out an alarm, something's wrong, so please wake up. The critical thing in this AI is it can't be an AI connected to the cloud. Why is this? It's because imagine if you enter a tunnel, then you lose your network connection. I mean, what happens if the driver gets sleepy in the tunnel? It won't be able to tell the driver that you're getting sleepy. And the tunnel is very important to use this application because it's where you get sleepy. So that's why we say it's very, very important to have the AI on the edge, in this case the car, to make it useful in real life. Let's look at a factory. I mean, voice recognition is going to become very, very important in factory environments. In the past, we had to touch machines and say, start, emergency stop. But in the future, I think voice will be more and more used, and especially with the coronavirus, we want to be as much touchless as possible. But it's not easy to use voice recognition technology in a factory because it's noisy. There's a lot of noise. And you have to be careful of who is talking to the machine. There might be a guy with a loud voice 5 meters from you, but his loud voice might reach this machine and it might start moving, which is actually dangerous if there's a person nearby. So what we're doing is we're developing technology that we can separate speech from first the background noise, the noisy environment, and also we're using this AI technology to be able to separate voices, detect whose voice is whose. We've even moved a step further with this voice recognition technology, and now we have a vocal interface without pre-language selection. In typical AI, first you need to select if it's English, Japanese, French, and then you speak the language and then it recognizes it. But with this technology, it detects from 10 languages simultaneously. So you don't have to set the language. Here's an example of it working.
I would like to go to the bookstore. Je cherche un restaurant français.
Japanese, English, French, and it automatically shows you where's the Chinese restaurant, where's the French, and where's the bookstore. Pretty cool, isn't it? Warehouse automation is also a neat place to use AI. But in reality, it's very, very difficult to use AGVs with human forklifts. Let's look at an example. This forklift is backing up. The AGV stops, It only can stop when you see a sensor in it. But this is not good, It has to go forward, then the AGV goes through, so you're losing a lot of time in the warehouse. But what if an AGV can think like a human being? The movement would be like this. moves forward, the AGV senses that he's probably going to back up, moves back, and it's going smooth. What we're doing over here, we're teaching the AGVs how these forklifts normally move in a warehouse, and they're going to learn it. And then they're going to be able to act like a human forklift. You have to be very, very careful that there's not only going to be robots in a factory. I always think there's going to be a combination where there's a robot, where there's an AGV, where there's a human, and they're all working together. And this is where I think AI will help, to help the collaboration between everything. Here's another neat application. It's AI video analytics for assembly. And what we're video analyzing over here is the skeleton print, which we call kotsumon. We're going to make a kind of role model skeleton kotsumon movement, and then we're going to compare other people to see if they're doing the right movement. And the cool thing about this technology is you can use a standard camera, and also you're reducing data collection analytics to 1/10 of what it was. Here's an example of it. So you see the red skeleton over here. What it's doing, it's checking how the skeleton moves, and it's kind of comparing it depending on the movement of the role model. So right now, get a part, inspect the part, put it on, and so on and so on. At the same time, it's also monitoring how much time it took each process. So this is very good for Kaizen activities. You can compare it against other people, or you can find if there's a bottleneck in your assembly process. Now it's in the final phase. It's doing the assembly of the screws. So putting on another screw, putting on the other screw. Okay. And finished. But a red light. What it detected is that he didn't do the final inspection. But the AI could detect that from the kotsumon, the skeleton print, and send out an alarm, okay, you better inspect the part before you go to the next phase. Pretty cool technology. We have other practical AI technologies like laser metal cutting, where we're using the diagnostics of the process data from sound and also light. And also, for instance, foreign object detection in a roll-to-roll application to find out which roll has the dirt or foreign object on it. At the end, I think the perfect AI is this, which is it's invisible. A lot of people in the factory do not have the knowledge of AI, do not have the knowledge of data analytics, and don't know how to use it. So what the most beautiful technology is something you can't see. And that's, I think, the way that AI should be in order to make it a better world. Like a robot cleaner, like a robot vacuum cleaner, which you just press a button, it's smart, cleans up in the most optimistic way, but you don't even know that AI is there. And this is what Mitsubishi Electric is pursuing in our factory automation components. We want to make AI that is very, very easily accessible to you. And please look forward to our new technologies that we're going to release into the market. Here's just some videos that I have on YouTube about digital manufacturing. If you're interested in AI, this AI applied to robots might be very, very interesting for you, where I specifically talk about AI and how they can help using robots and robotics in the factory. Okay, that's the end of my presentation. Thanks for listening and see you again.